so when we're thinking about slope, so if I think about slope, like here's the big drop, right? There would be a slope, okay? Coming back up, there would be a slope. I mean, even this flat part right here is a slope, okay? Everything kind of has a slope depending on how you look at it. Then you've got another down part. You've got a top part where there would be kind of a slope, okay? So there's slopes all over the place. And how we figure out slope, so if I zoom in kind of on this big guy here, so on the first big drop, you are looking at a triangle. That's what slope, that's how we come up with slope, okay? So when we're looking at slope and we're going to try to figure it out, we look at how tall or how high something is and how far out do you go, okay? So those are the two things that make up slope, okay? Also known as rise over run. Rise over run, okay? All right, so now let's put a few things in here. First off, slope. The steepness of a line. Okay, so slope is the steepness of a line. Okay, and I just said we know M, right? M is slope. And we talked about rise over run. Okay, and we're going to talk more about this here in just a little bit. Okay, so how high up do I go? What's my rise? Versus how far do I come out? My run. Rise over run. Okay, and if you need to put that in your picture here, you can do that. It would be rise and run. Okay. All right. All right, so now we also have a formula. Does anybody know the formula for slope? Anybody remember anything about it? Okay, so let's write this down then. M equals y2 minus y1 over x2 minus x1. Okay, so slope equals y2 minus y1 over x2 minus x1. Okay. Also in junior high, someone may have said to you at one point, change in y over the change in x. Okay, so if I'm thinking about this, this is mathematically, we're going to subtract our y values and subtract our x values. Or the change in y over the change in x is how you verbally would say that. Okay? All right, so there's kind of all the little bits and pieces you need to know about slope. Okay, so let's go ahead and let's go to the next page here. Okay, and then we have what's called rate of change. Okay, we're going to put a couple notes about rate of change. Okay, rate of change is a fancy word for slope. Okay, it means you're going to find slope. So when you see rate of change, you need to think slope. Okay, you also though need to think about it's always going to be applied to like a real world situation usually, or in some sort of table. Okay, and usually when we do rate of change, we need a decimal answer. And we need to label it. Okay, we'll talk about more of that here in a second. Okay, but rate of change is usually slope. Okay, and it shows the difference. So throwing in your lines here, the difference that we're subtracting. Between two changing quantities. Okay. Okay, now on slope, okay, you are usually going to leave this in a fraction form. Okay, so rate of change is going to be the decimal form, where slope we're going to usually leave it as a fraction form. I do expect you to reduce. Okay, that's a given. We always reduce our fractions. Okay, all right, so now it says the table below shows the distance a band marches over time. What is the rate of change? So when I see rate of change, I know my answer is probably going to be in some sort of decimal form. Okay. What does it represent? And does it matter what coordinate points you pick? Okay. All right. So when I'm looking at this and they're asking you to do rate of change, they're asking us for slope. And what we've talked about is that time is going to be always your what value?
Your x value.
Your x value. Okay. That is something you should already know. We've already talked about that. Okay, time is always going to be your x, and then whatever else, in this case we're looking at distance, will be your y. Okay? Now, these are just coordinate points. That's all these are. 1, 260, okay? 2, 520, 3, 780, 4, 1040, okay? So these are just coordinate points. So now, when I'm finding the slope, or rate of change in this case, and you're thinking about the formula, y2 minus y1, x2 minus x1, okay? And we're going to go ahead and use just the first two here. We're going to use this guy and this guy, okay? So now, when I'm looking at this, what do you think your y2 value is? Ashley?
The 520.
Okay, she says the 520. So if this is y2, then this would be your x2. Okay, so this would be your first x. So when you see x1, that's just your first x value. And then x1, that would make this y1. Okay? So she says we're going to take 520, and then what should we subtract from it?
The Y1.
Which is 260 over, okay, now x2 minus x1.
Oh, my bad. I thought it was good.
No, I mean, this is anybody, so what would I put on the bottom here?
2 minus 1.
2 minus 1. Okay? So now 520 minus 260. The calculator, let's go guys. And you're going to have some calculator work today. So if you don't have one, you might want to grab one real quick. But yeah, let's go.
260
Okay, so 260. What do you have on the bottom?
over 1.
Over 1. So in this case, we're going to reduce it to 260. Okay? So now this is what I'm talking about when I say decimal form. I mean, in this case, it's just a whole number. Okay, but you're always going to divide it out. So 260 what? What are we looking at here? What does this mean?
This is
260 feet, go farther,
per minute.
per minute, right? So if I look at this, we had 260 feet on top and minutes on the bottom, okay? So when I say 260 feet per minute would be your label there. So when I say rate of change, we're looking at slope, okay? Looking at slope. We're going to divide it down to one number, okay? And then you're going to label, all right? Now on the top it was feet, bottom was minutes, so it's just feet per minute. Okay, does anybody have any question about that so far? Okay, now, a couple other questions.
Wait, can I see the, I just want to see the full.
Okay, so now the next question is, what does it represent? Well, we just talked about that, feet per minute. Okay, so they're marching 260 feet every minute for whatever reason, whatever they're doing. Okay, now, does it matter what coordinate points you would pick here?
Yes.
So if I'm looking at this guy, would it matter? Would it matter if I took 4 and then, like, let's say the 2? Do you think you're probably going to get the same answer there?
No.
Okay, well, let's check it out. So let's put your y's on top. What would we put there?
You would do.
How would you set this up?
You could do 4, like the 4 and 100, 1040 SY2.
Okay, so you could call this, yeah, I'll change colors. So if this is going to be y2 and x2, right? So then it'll change this to x1 and y2, or sorry, y1.
Yeah.
Okay, so now when you subtract it, what do you get there? What do we put on top, guys?
Both sides.
Okay,
Yeah,
so what goes?
522. 520.
Okay, so he said 520 minus 1040, okay? I'm fine with that. It's okay if you put the 520 first. If you put the 520 first, though, what do you think you probably have to do on the bottom?
Just flip it.
Put the 2 first, all right? So if you start with this guy, then you got to start with this guy on the bottom, okay? So it really doesn't matter what's y2 and y1 and all that. It doesn't really matter. Just you subtract your y's. Wherever you start here, make sure you start on the bottom. So then I'm going to have 2 minus 4. Okay, so what is 520 minus 1040?
520
Negative, right? 520 divided by
is negative 2.
negative 2. So divide that. Do we end up with 260?
Yes.
Yes, we do. So does it matter what coordinate points you pick?
No.
No. Okay, you just need to pick 2 and go. It will not matter which ones you do. Okay? All right, so now